We looked at two white crystals, sugar and salt, looking very similar, tasting very different. We tried to melt them. The sugar melted quite easily with a Bunsen. In fact, it's very quickly started to decompose, but before it did, we tested the conductivity and there was no conductivity at all. So that means there are no free electrons in sugar and there are no ions in sugar, because in the liquid obviously particles can move. The salt, however, didn't melt at all, and so what we'll just do is we'll just check the conductivity of solid salt, which we have here, and we'll just check that this machine is working. We'll run it against some metal and say, right, that's working okay. So we'll test the conductivity on this solid lump of salt, and while it may contain ions, it's a solid of course, and so it doesn't conduct, which is not very surprising. Here we've got some crushed salt, and what I thought we might do is put some into water, but just to check. So we'll check this again. So here we've got the metal does conduct. The water with this tester does not conduct. So what we'll do is we'll put a bit of the salt in there, and in the process of stirring that up, whatever the particles are in salt, they will separate, go right through the water, and we'll just check the conductivity again. And when we do so, we find that it conducts very markedly. So we seem to have some particles in there which they can move because they're part of a liquid, and we think they're ions. However, maybe some special chemical reaction happened between the salt and the water. So what we'll do now is we'll take some of the salt from here and we'll put it into a crucible and we'll have a go at melting it. Now, with the sugar we used an ordinary Bunsen burner, and so we'll start off with this Bunsen burner here. We've got a special crucible which has got quite a high melting point, and we've just got it supported on a pipe clay triangle so it doesn't fall over, and we're just going to warm it up. Now we could wait for quite a while for that to heat, but I know that with the ordinary Bunsen it simply isn't hot enough. It's quite a hot flame, and so what we're going to use is an oxyacetylene torch, which will take the temperature, possible temperature, up to about 1500 degrees. So we'll just light this thing up. This is burning acetylene. We'll put some oxygen in there and give a nice hot flame, and we'll have a go at, you will notice yellowness in the flame, which is partly to do with the sodium compounds. Sodium compounds, they always do this kind of thing. They give a yellow flame. And we'll just adjust the oxygen to there. There's just got a wee bit too much in there. We'll just proceed to heat this. Now believe me, that salt is getting quite hot in there, and you may just be able to hear some cracking going on, and the reality is that, you know, the crystals actually crack apart, and we're applying a fair amount of heat there, and in fact it may even be possible for you to see the crystals jumping about. Not sure whether we can actually see that, but believe me, they are jumping about, and if we had that torch attached to our person, we'd be jumping about too, because it's very hot stuff. However, we seem to be getting somewhere, because from where I'm sitting, I'll just take the flame away from it, I think you can see there is actually a liquid in there. However, we'll just continue to heat a little bit more. We are applying a lot of heat to this. A very large amount of heat, and the salt is slowly melting. Clearly the particles are strongly attracted to each other, bonded if you want to use that word, and so what we're now doing is we're pulling them apart. I think what I'll do is I'll just heat it a little bit from the top, which will make an awful lot of yellow flame, but that's alright. We'll just get this stuff melted down, and if we look at it too much it'll give us yellow spots in front of our eyes. But if I take this flame away now, you'll see that we've got a whole lot of liquid in there. I'll just move it about so you can see it. It's actually, now that is molten salt. It's a liquid, it's a very hot liquid, it'll be over 800 degrees centigrade. We'll try the conductivity in this. So we'll put the conductivity probe into there, and look, it conducts very strongly indeed, so that in this liquid there are clearly lots of particles that conduct a current. Now I just want to heat it up again because I want to show you something else. So we'll just warm it up again because the Bunsen is keeping it warm, but it's not keeping it really hot enough. So I'll heat this up again, Because the question is, in doing this heating with sodium chloride, have we actually changed it? Is it no longer sodium chloride? What has it become? So we'll turn this off. And so we've got this water-like liquid here. We'll move this away. We'll lift this off here and we'll just pour it out onto this bench here. Now you'll notice that very quickly it goes back to solid, and you'll possibly see underneath it's pretty hot stuff. It's burnt the board. But what I'm prepared to do now, it cools very quickly, to take part of that, and it's still salt. It's just still salt. It hasn't changed from being salt. So even though we had it so hot, all we did in melting it is keep the particles free. And so I believe that those particles in salt are actually ions. And we could put that together in a model like this, that there's no such thing as salt molecules. And in this particular case, the green balls represent chloride ions, the silver ones represent sodium ions, and so we've got alternatively sodium ion, chloride ion, sodium ion, chloride ion, and so on, right through the crystal of salt. So those crystals that we were looking at are made up of structures that look like that. You can't say these two belong together or these two. It's a whole three-dimensional arrangement of alternatively positive ions and negative ions hanging onto each other very strongly, and I know that because the melting point was so high. It's over 800 degrees centigrade.